Hello, welcome back to Dubeke Consults, and today we shall be looking at column designs. As important as columns are in every structural design, for you to effectively design a safe, stable, and economical column, there are some basic principles and parameters that needs to be understood by the designers. And we shall be taking our time to look at these basic principles and how you can implement them in your column design. In the course of this series of lectures, we shall also look at how you can profile solutions to columns that are failing on your structural model. So if you find this video helpful at any point, do not forget to like it, subscribe, and turn on the notification bell so you get notified anytime we post new videos on our channel. Hello, welcome back to DBK Consult, and today we shall be looking at column designs with Prota Structure. So for you to complete your column designs, firstly, let's remind ourselves of the load transfer principles of our structural members. You will agree with me that our slabs, they transfer the floor load to our beams, which will in turn transfer this load to our columns, right? So it means before you go on to your column design, firstly, your analysis must be up to date, and also you must have completed the analysis and design of your structural slabs and your structural beams. So to do that over here, what we need to do is let's come to the analysis tab. Let's click here and we'll come to building analysis. Okay. So if we check our analysis, you will see that we do not have any active building analysis on this very model. Hence, we have this place ticked as X, right? So before we run our analysis, let's come to pre-analysis and let's set the concrete members and the reinforcement that will be used for our column designs. Okay, so we'll start with our project parameters, which is the code we intend to design the columns with. And for our concrete design code, we are designing with BS 8110 1997, right? So this is okay for our concrete members. For our steel members, the corresponding BS code BS 5950, right? And do not forget that before you even head on to this part, you must have done your load cases and your load combinations. Okay, so let's come back here, and the next thing we need to do is we select our reinforcement diameters that we prefer in our column design. So let's come here to edit materials and we'll look for our concrete columns. The grade of concrete, we'll leave this at 25/30, and our grade of steel, we'll leave this at grade 460. Now our rebar diameters, we'll unselect all of this and we'll be going with diameter 16, diameter 20, and 25, right? Let's pick these three diameters for our columns. So what we are interested in this case is our column design. So we'll leave others as it is and we can click OK. Okay. So the next step we'll be heading on to our analysis tab. So we'll click here and we'll run a quick building model check to ensure that we do not have any issues with the proposed design columns, right? So we'll give you a few seconds to run a quick building model check. So our building model check has been completed and the numbers of errors we have on this model is currently 0, right? So let's close this, and the next step will be clicking on this building analysis, right? So over here we have an icon for our column slash wall reinforcement design, and we also have an icon for our beam reinforcement design. So our column and and shear wall designs, or our column and wall designs, are always done together. They are always combined, right? Since they are both vertical members. So if we intend to design from this space, we can tick this, right? But I do not intend to design these columns. What I intend to design is my beams, right? So after designing our beams, because our beams must be designed before we head on to our column design. So I want the software to automatically design these beams for me, but I will prefer to design my columns myself, right? So I will click on reselect all bars and I will leave this column and wall designs unticked, right? So I will click on building analysis. So our analysis has been completed and we can close this, right? I can also click to, so let's also close this and this. So to see our current design status, what we need to do is come to visual interrogation and let's come to design status. So as you can see here, we have our beams in green, right? We have our beams in green, but we have our columns in red and yellow, right? So we do not have, or let's say our columns has not been designed. So the software has automatically designed for the beams, but not for the columns. So now let's head on to design these columns ourselves. Okay. So let's come to plan view and let's come to this design tab and we can click on our columns. Now these are the current columns on this very model from the story 1 up until the story 6, right? So these are all the columns on this very model. So what we need to do is we head on to settings and parameters because there are some important settings you need to check or you need to make modification to before you commence your column design. So we'll click on settings and parameters, right? And I said earlier, our columns and shear walls are always combined. They're always combined at the same tab since they are vertical members, right? So let's come to this design tab and let's come to this design tab. Okay. So for our minimum steel percentages, we'll leave this as 0 and 0 so it can use the relevant clauses or the relevant figures from our code of practice, right? And for our parameters here as well. So let's look at this design for ultimate axial load. So we can either use this clause or this other clause from our BS 8110. So as you can see, this clause it uses 0.35 FCU AC plus 0.67 ASC FY, right? So you can either use this clause using 0.67 and 0.35 FCU, or you can use this other clause that has 0.4 FCU and 0.75 ASC, right? So either of these clause is okay, but we'll be going with the default clause. And let's come to our rebars. So for this rebars here, for the selection method, we have the fixed bar layout method. So if you intend to go for this fixed bar method, what it does for you is you will have selected numbers of reinforcement, right, in your specific columns. Let's just close this and give it a better illustration. So let's say we open one of this column up and let's just take a screenshot. So we'll screenshot this and let's close this. Let's come back to our settings and let's come to rebars, right? So if we are to make use of if you have to make use of this first method, which is our fixed bar layout, which is the fixed bar layout, so what happens in that case is we will have selected numbers of reinforcement at their respective positions, right? So when we try to design for that specific column, it will not increase the numbers of these reinforcements, right? It will only try to increase the diameter of these reinforcements. So let's say we've selected this column to have this is 1 2 3 4 5 6. Let's say we selected this column to have 8 numbers of reinforcement, right? So against adding extra numbers, when this 8 numbers is not sufficient, what it will do is it will try to increase the diameters of this reinforcement in order to suit the requirements of that column. But this is mostly used or mostly effective when we are performing a redesign, right? This fixed bar layout method, it is mostly used or mostly recommended when we are performing a redesign. But in case you've not done your design and you want to start afresh, what I would advise is you choose either between the bar spacing maximization method or the bar size maximization method, right? So for the bar spacing maximization method, the column design will try to maximize the spacing, right? It will try to maximize the spacing between the bars, and it will do that by increasing the diameter of the reinforcement, right? So it will always attempt to increase the diameter of this reinforcement at a specific position in order to maximize the spaces between them, right? But as this bar size maximization method, so what it will do is maximize the diameter of our reinforcement, right? It will maximize the bar size. So what can happen in this case is, against always increasing the diameter of that reinforcement, okay, since it's trying to maximize that specific bar size, you'll be having a lot of that same type of reinforcement, or a lot of smaller diameters of reinforcement, okay. In this case, the spacing is being maximized, which means the diameters will most likely be increased. Let's say we have three numbers of the reinforcement in the specific column, or let's say we have four numbers. So it will still try to maintain that four numbers and increase the diameter, right? While for this case, it will increase the numbers of those reinforcements, possibly y16, and to increase the numbers of those reinforcements by maximizing that specific diameter. Okay, so these are the various settings you make. But for this case, always it is always preferably you start with your, or you go with your bar spacing maximization method, right? And these settings are relatable to these settings that we have over here, right? Which is the maximum spacings between our bar and the minimum column steel bar spacing. Okay, so we'll get back to discussing all of this, but it is always advisable you go with this bar spacing maximization method, or this is most likely useful when you are performing a redesign, right? And the next is, let's move from selection, let's come to the containment. So you can choose your different preferred link patterns. This is for the columns, this is for the walls. We are not designing walls at this point. So now let's come to our rebars. Okay, so for our column reinforcement size, the minimum is T16, as earlier selected from the project parameters, right? We selected T16, T20, and T25. So we have T16 as the minimum selected here, and the maximum for our column is T25. So this settings is for our shear walls, so we'll leave it as it is, right? Now this is the minimum column steel bar spacing, the minimum spacing between your column reinforcement. This is the maximum between your column reinforcement. So when you are going above this limit, or when you are going against this limit, right, your column design will always give you a warning. Okay, so if you're having your space between your reinforcements closely packed, let's say getting less than 25 millimeter, you will have to receive a warning that will uh, probably prompt you to increase the size of the reinforcement. And also, if you have the spacing between your reinforcements going beyond 200 millimeter, it will also give you a prompt, right? So this is the maximum wall web bar. This is for our shear walls. This is for our shear walls, right? So we'll leave this as it is, and this is our concrete cover. So this is the concrete cover of our columns, and if we leave this at 0 millimeter, it will automatically select 25 millimeter, right? So if you intend to keep your concrete covers above 25 millimeter, you can as well come here to edit to the preferred concrete cover as regards to your need for the specific project. All right, so we'll leave this at 0.0 millimeter, and it will automatically select 25 millimeter as our concrete cover. Now we'll come to our links. So if you found this video helpful at any point, do not forget to like it, do not forget to subscribe, and you can also go through our YouTube channel. We have different courses to cover different design concepts, right? So do not forget to like, subscribe, and turn on the notification bell so you always get notified anytime we post new videos on our channel. The link's diameter we can select, we'll keep this at 10 millimeter. Then the minimum spacing between our link, we'll keep this at 100. The maximum between our links are as well known as our stirrups, right? So we'll leave this at 300 millimeter. Link step 25, and this is for our shear walls, right? So we did not select any mesh for our shear walls, and we are also not designing our shear walls. So we'll leave this as it is. So since we have a proper understanding of our project settings and parameters, let's click OK to use these parameters, right? So after setting this, or after making your preferred modification, the next thing you need to do is come to our column design batch mode, right? So if you intend to design for the columns on a specific story, you can come here to select your preferred story of design. But since we are designing for the columns on all the stories at one go, right, we'll leave this at all stories. So we have three different design options here. The first is to check still and select new still when previous bars are insufficient, right? So what this will do is it will check your reinforcement in, or it is if to check your concrete section, and if the previous reinforcement provided was not sufficient, right? If the previous reinforcement provided for the specific column was not sufficient, it will select new reinforcement in order to meet the new requirement of that specific column, right? And this is mostly useful when you've done a previous design. Okay, this is mostly useful when you've done a previous design. Now the second option here is to check still and do not select new still when the previous one are insufficient, right? So it will check the columns. This is also mostly useful when you are performing a redesign. Let's say you've done a previous column design and you possibly made some modifications to, it could be to the column load, or it could be the beam arrangement that are transferring load to that specific columns, right? So that is where two of these options are mostly useful. So for the second case, it will check the concrete section, it will check the reinforcement in the concrete section, and if the previous reinforcement are not sufficient, it will not attempt to select a new series of reinforcement. It will only show you that the columns are insufficient, right? But since you are performing a fresh design, what we need to go with is we select all bars. So it tries to design all of these reinforcements from scratch. Okay, so we'll click on reselect all bars and we can click on calculate. So when this process has been completed, you can click on this close button, right? So these are the columns we currently have on this very model, right? These are the columns we have on this model from this part down to combine, and this combines all the columns on all the stories, right? So if you want to see the columns on each of the stories, you can filter by stories and you select what your story one or your story two if you intend to, modify these columns per story, right? But we'll be picking some random columns, so we can look at how you can investigate the column design and possibly make modifications to your preferred columns, right? So as you can see over here, we have some passing columns. These are the design status. These are the column dimensions. This is 225 by 600, 225 by 600. This is utilization ratio. And these are the reinforcements in the specific column. And we also have what? Some filling columns on this very model, right? We have some columns that are filling. And to appreciate this better, let's go to our 3D view in order to look at these filling columns, right? Let's go to our 3D view. Okay, so if you close this, and as you can see, these are the columns, these are the filling columns. So mostly we have our columns filling on our story 2 and our story 1, which is our ground floor and our first floor, right? So we have most of this column filling on the ground floor and on the first floor, right? So let's come back to this part and let's maximize this, and start by we can start by investigating some random columns, right? So I can select any column. Let's look for a column with a high u ratio, and a high let's check with this that is having a high utilization ratio of 97%. Okay, so let's select this. And as you can see, the column identity of this specific column in question is 4 column 4. It means this is column 4 on the story 4. And these are the these are the column dimensions. We have it to be 225 by 450 millimeter column, right? These are the reinforcement provided. On at the corners, we have one numbers of T20 provided at each corners. So this is our diameter 20 reinforcement provided at each of these corners, right? This is the direction 2 internal member. So we have one number of this reinforcement provided here. At the direction 2, we have one numbers of reinforcement. This is direction 1. If we take this to 1, it will bring out one numbers of reinforcement on this other axis. Okay, so let's take this downward. So if we intend to enhance the properties of this column, what we can do is, just like we have one number of this reinforcement on the direction 1, we can increase this to two numbers, and as you can see here, the U ratio will be increased from 0.71. It will increase from 0.9 plus to 0.71 because we've actually increased the numbers of reinforcements in this column, right? So let's take this down to back to one number, and let's see what happens when we try to reduce the diameter of this reinforcement. So if we take this from here to 16, and let's click somewhere else, so you can see the it means y16 at these corners is not sufficient for this column. And also if you take this to y16, it also means y16 at these corners is not at this midpoint is not sufficient for this column. So let's say we intend to maintain y16 for our columns, right? So what we can do additionally is trying to increase the numbers of this reinforcement in this column. Now firstly, let me take this back to y20. Let me take this back to y20 as well, and this is the U ratio. And let's come to the shear design, because if you're talking about our shear design, we are talking about our links, right? We're talking about our links or our stirrup, as we may choose to call it. Now one thing you shouldn't forget is, if you are designing your columns with a bigger size of reinforcement, due to the fact that this reinforcement has a bigger diameter, you will most likely require a higher spacing between your stirrups, right? Because the reinforcement have a bigger diameter. But if you're using a smaller diameter of reinforcement, you will see that your reinforcement will most likely be stacked at a closer distance. So firstly, let's calculate the shear reinforcement, which is our links for this column. So we can see we have T10 running at 225 millimeter, right? This is T10 running at 225 millimeter. So let's come back to our steel bars. Let's come back to our steel bars, and let's take this to 16, and let's also take this to 16. But in order to satisfy our U ratio, let's increase the numbers of this reinforcement. Okay, so as we have these numbers of reinforcement, we have 2 here, 2 4 6 8. We have 10 numbers of y16, right, against 6 numbers of y20, right, which is actually sufficient now because this is below 1.0. But we'll come back to our shear design. Let's see what happens. So as you can see, due to this rearrangement, we now have double links here. We have double links here, and we also have our links running at 175 millimeter, right? So when you are trying to reduce the diameter of your reinforcement that will be used in your column design, or that will be used in the construction of your structure, you should also consider other cost implications that will affect that specific design, right? Because the cost of running a diameter 10 reinforcement at 225 millimeter is not the same cost as running a diameter 10 reinforcement at 175 meter. Let's say you have let's say you have a 3-meter height of column, right? And you have to run the stirrup at 225 millimeters center to center spacing. So if you divide it by 225, so it means we'll be requiring 13 numbers of these links on the specific structure, on the specific column, right? But if we have the same 3000 millimeter, and this is running at 175, it means you are requiring 17 numbers, right? So you can compare the cost of this additional reinforcements compare it to, let's say you can compare the cost of this y16, compare it to the cost of 6 numbers of y20, and also compare the cost of your link. So this is what can make you come out cost economical design. But the first, you shouldn't forget that your first principle is ensuring what? Safety, right? So the column is safe in both cases. It's actually safe in both cases. Or the best thing is for the column to be safer at y20, what we can do is, let's take this down to, we can take this to 2 numbers and make this y20, right? Yes, you can take this to 2 numbers and make this y20 and make this y20, right? So you shouldn't forget that after safety, you should also be what? Considering your cost implication. Okay. So this is how you can modify each of your columns, right? So let's go ahead and we can either leave this as it is, because I'm not too comfortable with having this 97, sorry, 97 or between 97 95 u ratio, right? So I will take this to 2 numbers, okay, and I can click okay, right? So what I will advise is, in the process of your column design, always ensure you open each and every of your column, right? Ensure you open each of your and every of your column, because don't forget that structural engineering, you are dealing with life and you're dealing with properties. So just because the u ratio is good, it doesn't mean you just adopt that column, right? I will always advise you open each and every of your columns in order to understand what is going on and the modification you can make in order to suit your own personal requirement as a structural designer, right? So one thing you observe is, even with the fact that we've increased the reinforcement properties of this column, we still have the U ratio here as 97%, right? We have this as 0.97. So what we can do in order to remedy this is, we've also already increased the reinforcement properties to or reduce it to 0.71. So we also have to work on our concrete properties, right? So let's take this to 500. Let's take it to 500 millimeter, and let's update. Come to interactive design. So with the increment in size, you can see that we only require 6 numbers of reinforcement. So we now have what? Let's stick with these 6 numbers of T20 and let's click and let's see if there are any changes. Okay. So as you can see, by increasing the diameter, by increasing the concrete properties, we now have this to be 0.88, right? So do not forget your U ratio is a combination of both your concrete properties and your reinforcement properties, right? So let's investigate some other columns, and let's start with the first column on this very model. So we have this to be one column one, which is the first column on this story one, right? So let's open this up, and these are the column properties. We have it to be 225 by 600 column, right? And these are the reinforcement properties. This is the governing design load case, right? This is the load case that has the maximum effect on the column. Hence, it was used for the design of this. In our reinforcement properties, the U ratio, we have this to be 0.81, right? So firstly, one thing I always advise is always check your interactive design for each of the columns, right? As you can see here, we have this to be 225 by 600 and it's quite okay. So if you click on our interactive design, we'll be able to get some information about these columns, right? So if everything is okay, you probably do not get any error message, just like the last column we checked. But as you can see here, we have what? Axial load upper limit is exceeded at loading 2. And as you can also see here, the combination that was used for the design is our combination 2. So we have the axial load upper limit is exceeded, and it gives us an alternative in order to solve this issue. So it says our section sizes must be increased, right? So it's speaking specifically to our section size and not our reinforcement size, right? So what we can do is, let's click OK, and let's try to increase the properties of this column, right? Firstly, I will increase the concrete properties to 250 millimeter. Okay, you can update this, and let's click on interactive design. So as you can see, 250 has actually increased the properties of this design, of this specific column. And now we have a different reinforcement arrangement, right? So we now have what, only two numbers of this reinforcement, right? We only have two numbers of this reinforcement at the direction 2 of the column. Previously we have three numbers of this reinforcement at the direction 2 of our columns, right? So increasing this from 225 to 250 has actually increased the properties of this column, and our U ratio has been modified to 0.74, right? So don't forget, as said earlier, the overall properties or the overall strength of your column lies specifically in both the combination of your concrete properties and your reinforcement properties, right? So let's see if we can further increase the properties of this. So if we take this to 700 and we update this, let's update this, and we can click on our interactive design, right? Can click on our interactive design. So our U ratio has further been increased just by an additional 100 millimeter. Okay, so this is 0.57, and now we require what, T16. Okay, now we require T16 for our shear reinforcement. We require T10 as 175 millimeter. Okay, so we can actually go ahead to, if we intend to take this back to 600. Okay, just let's click on interactive design. Always click on your interactive design after every modification you've made on your column, right? So click OK, and now we require T10 at 225 redesigned, and for our steel bars we require T20. So you should make the modification and look at what is best for you and what is best for the structure, right? So always open up every column design to understand what is going on that specific column, right? So we can stick with this as our properties, right? So the next thing we'll be looking at is, let's design some fade columns, right? So let's close this, and let's select some of these fade columns to design. Let's pick any specific one. We can start with let's start with this. Let's select this, we'll right click, and we'll come to our section design, right? So as you can see, this is the reinforcement arrangement in our columns, and this is our U ratio of about 5.75, right? So let's see how we can solve issues like this when you encounter them. If you found this video helpful to this point, please do not forget to like it, subscribe, and turn on our notification bell so you get notified anytime we post new videos on our channel, right? So to understand what is going on this column, I will just simply come to interactive design, and the warning here says steel bars cannot be selected, section size is insufficient, right? So the interactive design gives you an idea of what is going wrong with this structure. So without further investigation, I do understand that I need to increase the section properties of these columns, right? So let's start working. As you can see here, we have what, section insufficient, also what, in shear design. Okay, so what we can do in this case is let's increase the concrete properties of this specific column. So if we take this to 250, right, let's update, and let's check an interactive design. Still insufficient. Okay, so this is 250, and let's take this to 700. Let's see, this is still insufficient. So let's take this to about, let's increase this part to 300, because in this case we are dealing with what, the section size, right? We are first dealing with the section size before we speak about the reinforcement. So this is now 300 by 700. So let's check this. This is still insufficient. and let's try 700 and what 50 millimeter. So if we update this and our interactive design, so this is okay, right? This is okay. So it means this column size for the section to be sufficient, we should be requiring about 750 millimeter by 300 millimeter. Okay, let's cancel this. Let's cancel this. As you can see, this column is actually on the ground floor of this design, right? So this is more reason why it requires a lot of a bigger section size, so that the ground floor and is receiving load from some cantilevers and also receiving loads from all of these other stories. So it will require a bigger section for design, right? So always look at the requirements of your column and try to relate it with what is going on that specific column on your structure, right? You shouldn't just increase the size of the reinforcement or increase the concrete properties. Always look at the column and try to relate with the functionality on your specific structure in question, right? So we'll select this and we'll come back to our section design. So let's take this back to 750 and we'll take this back to 300, right? And we can update this. Come back to our interactive design. Our section is insufficient now. It's sufficient now, right? So we can click OK. So this is the U ratio of the reinforcement. If you intend to, and this is, as you can see, this is requiring T25 at the corners, right? And 4 numbers of T25 at this direction. Okay, so this is what can pass this column. So you can decide to increase the properties if you feel it is not you're not okay with this, but I'm okay with this, so I will have to what click. And let's look at our share design. So due to this bigger size of reinforcement, as you can see here, we have what T10 running at 300 millimeter center to center spacing for our shear reinforcement. Okay, so with this, and this is how you can pass some filling columns on your model, right? Let's also look at this and let's come to section design. Okay, this is a 225 by 600 column. If we come to our interactive design, so the section size is what's insufficient as well. So let's take this to 250. We'll update this and let's check. So steel ratio limit exceeded, right? Steel ratio limit is exceeded in this case. Okay, so let's also increase the section properties. So let's take this to about 750 with the previous column. Let's update this and let's check our interactive design. So uh, a size of 250 by 750 is actually sufficient for this specific column, and these are the reinforcements required. T20 at the corners. Let's see if we take this to 300. Let's see if we take this to 300 and see what happens, right? So in this case, we have what 5 numbers of this reinforcement at the mid part, and we have 1 numbers at the corner, all T25. So if we go to interactive design, so as you can see, due to this increment in size, we now have 3 numbers here against 5 numbers, and we have an additional 1 number of reinforcement at this mid part. Okay, we have an additional 1 numbers, which makes a total of 4 numbers. So compare the cost of these 2 numbers with your concrete properties that has been added to with the 50 millimeter concrete that has been added to the previously existing 250 millimeter. Okay, this is how you always come out with a cost effective design. So our share design, we now have this to be T10 running at 300 millimeter center to center spacing. Okay, so with this understanding, we can click okay, can see this specific column design. So this is how you can solve each of your filling columns, right? And this is how you can perform column design with Prota Structure. If you found this video helpful till this point, do not forget to like it, do not forget to subscribe and turn on the notification bell for you to get notifications whenever we post new videos on our channel. Okay, so see you in the next series.